All right, welcome aboard. Today we're starting a new unit. We're starting Unit 8, which is Organic Chemistry. So, without further ado, let's get to it. And this is Unit 8, Organic Chemistry. Our first lesson, 8.1, is alkanes, alkenes, and alkynes. We'll talk about each of those in turn as we go through the day. First of all, organic compounds, what are they? Organic compounds are those that contain primarily carbon. So organic chemistry focuses on these carbon-containing compounds. A couple of really important details as we get started in this unit. All carbon atoms make 4 bonds. No more, no less. So always make sure, you're drawing a lot of C's this unit, always make sure that they have 4 bonds. A point off if you give them 5. It's a point off if you only give them 3. So always make sure that you're getting 4 bonds on all of your carbon atoms. In addition to carbon, you're also going to be drawing a lot of hydrogen. So again, hopefully a little reminder from first semester. Hydrogen atoms only make 1 bond. So recall, they only have 2 electrons and the 1s orbital, and so they're only going to form 1 bond. So never give hydrogen a double bond, never bond them to 2 different atoms, never have more than 1 bond on a hydrogen atom. All right, how this unit is set up is I'm going to give you a set of rules, and with those rules, you can apply and you start to build bigger and bigger items. The first rule, kind of the building block, the foundation on which this is all built, is that organic compounds are named based on the number of carbon atoms that they contain. So that's going to be our first rule, is you're always counting how many carbon atoms are in the molecule. So there are some prefixes that we have to learn that tell us how many carbon atoms. So there's a little data column here. So number of carbon atoms and prefix. So what prefix goes to the number of carbon atoms? I'm actually going to duplicate that over here. So we just kind of continue our data column on down. Instead of taking up half the page, take up both parts of it here. All right, so number of carbon atoms. If you have just 1 carbon atom, the prefix is meth. 2 carbon atoms, your prefix is eth. 3 carbon atoms, your prefix is prop. 4 is bute, not but. That's bute. So these first 4 are probably new to you. Meth, eth, prop, bute, MEPB. So whatever it takes, you're going to need to memorize these. You're going to need to know them. These are probably the most common 4 you're going to see. So MEPB, memorize kind of that order. Meth, eth, prop, bute. You've probably heard of prop, whether you realize it or not. If you have a gas grill outside that you or your parents uses, more than likely the fuel in your gas grill is propane. propane. So that's a carbon or a molecule that contains 3 carbons, propane. All right, after number 4, these should start to look a little more familiar to you. We have pent, it's like a pentagon. I think we're all pretty familiar with 5. 6 carbons is hex. So again, I think we're all pretty familiar with a hexagon. 7 is hept. Probably heard of that one before, heptagon. 8, we all know. 9, again, might take a little bit of studying, but 9 is non. And 10, we probably all know. Deca, like a decade or a decathlon, they all deal with 10 somehow. Make sure we are comfortable with these prefixes. That's kind of the building block on which all the rest of organic chemistry is built. We'll start off with alkanes then. So alkanes are carbon chains that contain all single bonds. These are also known as saturated hydrocarbons, which means saturated is Greek for full. So these are full, or they have the max number of hydrogen. So alkanes have as many possible hydrogen as they can. We call them saturated hydrocarbons. We'll talk about that more in a little bit. It should be a little bit easier to see once we've done a few examples. When you're naming alkanes, again, those are the single bonded carbon chains. They end in A-N-E. It's going to be the last 3 letters of any alkane you're doing. So let's take a look at some examples. One carbon, again, double check, make sure it has all 4 bonds. We drew those. What do we put on the end of those bonds? Hydrogen. So the hydrogen each makes 1 bond, the carbon makes 4 bonds. All right, so just 1 carbon. We double check our prefix for 1 carbon, that's meth. There are only single bonds here. So we add the ending ane. That's methane. It's methane, a gas produced by cows, the greenhouse gas. We produce it too, but just not in the quantities that cows produce it. Next up, we have 2 carbons. Again, let's make sure they all have 4 total bonds. Now this time, each carbon is bonded to one another. So that means they've each already got 1 of their 4, so we'll need to add 3 more bonds to each of them. And again, on the end of those bonds, we cover them up with hydrogens. We look up here, our prefix for 2 is F, again, all single bonds. So we call this ethane. F tells us there's 2 carbons. The ane tells us that there's all single bonds. Let's do a little longer one. So here we go, 6 total carbons. Again, let's make sure everyone's happy. The 2 on the end, the 2 carbons on the end, they both need 3 more bonds. They've got the 1 attaching to the chain. Each of these guys in the middle, each of these carbons in the middle, they've already got 2 bonds because they're attached to both of their neighbors. So they only need 2 more. And again, we cover up those empty bonds with hydrogens. And we name it. 6 carbons. Our prefix for 6 is hex. all single bonds, so we put A-N-E at the end. Hexane. Hexane. That's the name of that one. Next up, we'll take a look at cyclic hydrocarbons. There are cyclic hydrocarbons here. These are cyclic hydrocarbons. Cyclic, so the cyclic kind of means it's in a circle. These are carbon structures that form a ring. And I know I told you when we named molecules last chapter, never, ever, ever draw shapes. You know, don't draw pentagons, don't draw squares, don't draw triangles. Well, in carbon chemistry and organic chemistry, that's not always the case. You are allowed to draw rings. Sometimes you do. When we name them, it's pretty simple. We simply put the word cyclo, which sounds like a circle, so it should make sense, in front of the parent chain. Let's take a look at some examples. So there's 4 carbons. They're in a ring. They're all connected to each other. Again, let's make sure they're all happy first. They've all got 2 bonds, so they all need 2 more. Go ahead and put hydrogens on the end of all of those. 4 carbons. Our prefix for 4 is but. They're all single bonds, so we'll put ane, and they're in a circle. So again, the word for circle is cyclo. So this is cyclobutane. Odd looking shape, sorry about that. It's going for number more than shape. And let's go ahead and start by making sure that all these carbons are happy and they have their 4 bonds. Always got to make sure we do that. Again, it's going to be a point off every time you give a carbon too few or too many bonds. All right, there we go. Total of 7 carbons. Our prefix for 7 is hept. They're all single bonds, so A-N-E. They're in a circle, so cycloheptane. Again, that's what each of these building blocks tells us. 7 carbons, single bond, and a circle, and a ring. Next up, we have alkenes. One letter different than alkanes. So alkenes are hydrocarbons with at least 1 double bond. When we're naming them, alkenes end with E-N-E. So if that kind of makes sense, alkanes ended in A-N-E, alkenes end in E-N-E. So here's 2 carbons, a double bond between them. Again, let's make sure they're satisfied. Now, they each already have 2 bonds, so they each only get 2 more. Now, whether you put those 2 top and bottom, left and top, top and bottom, it doesn't matter. not for this class, and actually not for this molecule, but just make sure you get the proper number of bonds and additional hydrogens added to your structure. All right, we go ahead and name then. F tells us there's 2 carbons. Ene tells us there's a double bond. So 2 carbons with a double bond. So again, each of these pieces kind of works together to tell us what it is we have. So another example, again, watch out, this guy in the middle, he's already got 3 of his bonds. So he only gets 1 more hydrogen. Don't give him another one, that'll be a 5th bond, and that's worth a point. And same thing, this guy in the end, he's already got 2, so he only gets 2 more. 3 carbons, our prefix is prop, there's a double bond, so we call it propene. Propene. Next up, we have alkynes. Bet you could take a, sorry about that, bet you could take a guess as to what alkynes are. Alkanes had all single bonds. Alkenes had at least 1 double bond. Alkynes have at least 1 triple bond. Alkynes end with Y-N-E. So some of you guys are probably already speaking the language and probably saw that before I even wrote it up here. 2 carbons, triple bond between them. Again, count how many bonds you have. They each only get 1 more. They've already got 3. They only make 4 total. So they each only get 1 more. F is our prefix. Y-N-E tells us there is a triple bond. So 2 carbons, triple bond between them. Now this is the proper name, the way we should be naming it. However, this also has a common name that we should be aware of. So there's a lot of common names out there. Some of them are so common you might not even realize they're common. For example, dihydrogen monoxide. That's the proper name for water. But we also commonly know it as water. We don't call it dihydrogen monoxide. Perhaps we should. Acetylene. So this is acetylene. Perhaps you are not so aware of it, but at some point it'll probably be a term you hear of. It's blowtorch fuel. So you're seeing someone welding with a blowtorch, but they're burning super hot and super bright is acetylene. One more example here of an alkyne, and there's that triple bond. Notice this carbon in the middle, he's already got all 4 of his bonds. He's got 3 there and his 4th one there, so he will get no hydrogens. And the guy in the end, he only gets 1. He's already got 3 of his 4 bonds. He only gets 1 more. Okay, 3 carbons, we say that with prop, Y-N-E, propyne. Propyne, there is a triple bond. So we mentioned saturated before. We talked about alkanes. Alkenes and alkynes are not saturated because they don't have the maximum number of hydrogens. Again, we look up here at this triple bond. both of these carbons involved in the triple bond could have more hydrogen. They could have more hydrogen if they just had a single bond there, that each bond to 2 more hydrogen. So it's not the maximum number of hydrogen in that molecule. So we call them unsaturated or not full of hydrogen. That's a really important concept, saturated versus unsaturated. Hopefully you guys had a chance to talk about that in biology last year, but if not, unsaturated, generally considered a lot healthier than saturated. It's not something we're going to get into a ton right now or in this class, but just know that there is that big difference between unsaturated and saturated hydrocarbons. Again, it all has to do with whether or not you have a double or triple bond, and therefore can or cannot have the maximum number of hydrogens. All right, next up, this is where I think it really gets fun. Numbering alkenes and alkynes. All right, so once your chain is longer than 3 carbons, we have to use numbers to signify what carbon the double or triple bond starts on. Best to show with an example, so note the difference here. So our difference between 1 butene, so but tells us there's 4 carbons, the ene tells us that there's a double bond. So start by drawing my 4 carbons. There's a double bond. Again, make sure everybody's happy, fill them up with 4 bonds each. Guy in the middle here, he's already got 3, only gets 1 more. Guy on the end, he's already got 2, he only gets 2 more. So there's 1 butene versus 2 butene. So but tells us there's 4, there's a double bond, but look what that 2 tells us. It's in a different place than the first double bond. So this is what we mean by numbering alkenes and alkynes. And 1 butene, the double bond, starts on the first carbon. And 2 butene, the double bond starts on the second carbon. So there's 2 different butenes, and we need numbers to specify which one we're working with. Very important rule here, and it takes some getting used to. Very important rule, and it takes some getting used to. The lowest possible number must be used on your double or triple bond. Why that's so important is in organic chemistry, that right to left or left to right makes no difference. I know we're so used to reading left to right, but in organic chemistry it doesn't matter. Sometimes you can number right to left. And all that matters is getting the lowest possible number on the double or triple bond. So the idea is in organic chemistry, those organic molecules are a three-dimensional object, kind of like this pen, and it doesn't matter if the pen faces this way or faces this way. It's still the same pen. And kind of the same thing with organic molecules. It doesn't matter which way it's facing on paper or in real life. The name won't change. So there we have our 5 carbons. We've got our double bond. Make sure all the carbons have their 4 bonds. You can watch these 2 in the middle. They've already got 3. Now, if we name this left to right, five carbons, the double bond starts on the 3rd carbon. We'd call this 3-pentene. So pent tells us there's 5 carbons. Ene tells us there's a double bond. The 3rd carbon is where the double bond starts. The problem with that, though, is that we could come back right to left and number it this way. And if we do, now the double bond starts on the 2nd carbon. 2 is lower than 3, so guess what? 2-pentene is the correct name of this molecule. So always watch out. Don't have any problem numbering right to left, left to right. If you look at my my homeworks from organic chemistry, my notes from organic chemistry, I've got numbers going in left, right, top to bottom, all sorts of different directions. What's important is making sure you find that lowest number, whatever you have to do to find it. All right. All right, one last special note here. So for cyclic carbons, cyclic carbons, so there's ones that go around a circle, it doesn't really matter where you start, which means you get to pick which of your carbons is number 1. So that being the case, and this being the rule, always choose to start on the carbon that has the double bond. Put the double bond right there, and let's go through and make sure all the hydrogens are on this atom first and foremost. I hate to lose points because it moved too quickly and forget to do that, so I'm just going to take care of it while I got the time. Right, there we go. Okay, so we have to start with 1 right there and 2 right there because we have to make sure that the double bond is on the lowest possible carbon. Since it's a cycle, I can make any one of them number 1. There is no real beginning nor end. So I'm going to call that number 1 because that's where the double bond. And then here's the catch. So because this has to be number 1, there's no other way I can write that. That has to be number 1. I have to satisfy the rule up above. So because of that, whenever you only have 1 double bond on a cyclic hydrocarbon, you don't need to number it. You don't need to put that number in your answer. So again, we've got 6 carbons here. We'll call this hex. We've got a double bond, ene, and they're in a circle, so we'll call it cyclo. but we don't need to put the 1 out in front. Even though this is longer than 3 carbons, there's only one place that that double bond can possibly be. And that is on the very first carbon, so it's considered redundant to put 1 cyclohexene. We know it's on the first carbon. That's the only place it can be. So writing just cyclohexene is most proper. I'll be honest, I probably wouldn't take off any points if you did put 1 dash cyclohexene, but you don't need to. It's most proper just to write cyclohexene because everyone knows
Good morning,
it's the only place it could
Today
possibly
you will
be.
begin in period 5. Again, you will
All
begin.
right, so we're getting some
in period
announcements
5
here about to
today.
start the day.
Have a great day.
Hopefully those notes work for you. And we'll see you back here next week for our next lesson in organic chemistry.